All right. We are solving equations, and in this section, we're solving all kinds of equations. Linear equations, and quadratic equations, and rational equations. All kinds of stuff. Like this is all of Algebra 2 in the next 3 days. Or 2 days. We do it in 2 days. Okay? So hopefully all of this stuff goes okay for you. But again, being that it's pre-cal, we're going to throw in a couple of curveballs as well. So, be sharp and think through your stuff. So here we go. Example 1, solve the equation and check your solution. Is that warm in here to you?
Yes. Cameron. Sorry. Wow, this is the fun.
It's like the air is on in the morning and then it gets hot and the air turns off. So I just don't understand what seems to be happening. Okay. All right. So here we go. Checking your solution, ladies and gentlemen. There are lots and lots and lots of ways to check your solutions. Again, this class, because of how I ask the questions on tests and stuff, being able to check your answers correctly is key, right? When I throw you those none of these question answer choices, you really have to be able to prove to yourself, hey, did I do this correctly? And we'll talk about all kinds of ways to do that. But there's a couple of ways that we can check our solution on a regular sort of equation like this. Obviously, plugging in the answer is a great way to double check. So just to solve this linear equation, it's a linear equation, what do you want to do? There's lots of different ways, so I want to hear from you. What are you thinking of doing? Okay, I hear 2 things. Good. Okay, so I heard 2 things. I heard get rid of the fractions. All right, get rid of the fractions. And I also heard the common denominator way, which also works. So I'm going to start with the common denominator method, and then we'll do the get rid of the fractions altogether method. Because some of you, if you had college algebra, you learned the LCD. If you had algebra 2, you probably didn't. Especially if you're my student, you didn't. So common denominator, we need to add these terms with x together. And so I'm going to take my fractions and get a common denominator. What would my common denominator be? 12. So I'm going to multiply this first fraction by 4 on top and bottom, and my second fraction by 3 on top and bottom. That's going to give me a common denominator of 12. And what's in the numerator? 4x plus 9x. Okay. And then, of course, 4x plus 9x is 13x over 12. Okay, so you can absolutely work fractions just getting a common denominator. And then how do I get x by itself here? You can multiply both sides by 12 and then divide by 13. Can I multiply by 12 over 13? Yeah. Multiply by the reciprocal? That works as well. Okay. So 13 on top and 13 on bottom reduce, and the 12s would reduce, and I'm left with an x, 1x, is equal to 24 over 13, which is a perfectly wonderful answer. Okay? Don't be scared of fractions. They happen more often than integer answers. Okay. Now, the other method The other method is to multiply through by the LCD, the lowest common denominator, which is a great method, but it's kind of a hit or miss method for me as a teacher because some students get it and some students don't. So when I look at this, all of these denominators, I have a denominator of 3 and a denominator of 4 and a denominator of 1. What number do they all have in common? 12. 12 is the least common multiple, the number that's bigger that they both go into. All right? Least common multiple, lowest common denominator, same thing. What we're going to do then is I'm going to take my equation, and this works all the time, anytime you have denominators. I'm going to take my equation, and I am going to multiply the left-hand side by 12, and I'm going to multiply the right-hand side by 12, which is allowed, right? Because I'm doing it to both sides?
Yes.
Okay, so I'm keeping things balanced since I'm doing it to both. Now, since I'm multiplying this entire left-hand side by 12, what do I need to do? Yeah, you have to distribute it to all the terms in there. And when I distribute it, I'm going to get 12x over 3, which is really what? 4x. And because it's 12 over 1, remember? And then when I distribute it to the 3/4 x, 12 times 3 is 36x over 4, which becomes 9x. You'll notice what happened to the fractions. They're gone. They cleared. And that's equal to 2 times 12, or 24. And so again, 13x's equals 24. And we divide by 13. Okay? Now, I just did a problem 2 entirely different ways, right? 2 different methods. Is that an acceptable check?
Yes.
Sure. 2 different ways, and you get the same answer. That's a good check. All right? Of course, you can always take your number, and your calculators can be really helpful just plugging it right back in. You have calculators, and you plug in that left-hand side, and you should get 2 as your answer. All right? So plug those values back in. All right, questions on that one? Okay. Letter B is not a linear equation. This one is rational equation. What does rational mean? Rational, fractional. Good. It's a rational equation. This one had fractions in it though too, so what's the difference between them?
There's no X.
Yeah, there's no x's in the denominator. That's really what makes it rational when we have x's in the denominator as well. Really changes the graphs. This is just a line. Okay, so on this one, I'm going to get to it in just a second because it's kind of interesting. I got to do a little bit of a logic test on you. Okay, so I'm going to get here in just a minute. So, x plus 5 equals 8 plus 5. What's x? Right up here. X plus 5 equals 8 plus 5. It's 8. It's 8, right? Right? Okay. Okay. So x over 7 is equal to 13 over 7. What's x? 13. Okay. So x plus 5 over 7 is equal to 13 plus 5 over 7. What's x? 13. All right. You didn't have to think too hard about that, did you? Okay. I just want to make sure because sometimes we lose ourselves in math processes and forget what an equal sign actually means. So when a problem has structure that matches, it's quite easy to say, oh, those are in the same place. They're supposed to be equal. All other things are equal, so those must be equal. Does that make sense to you? They're supposed to be equal, and the structure is matching, shall we say, okay? So when we have fractions like this, if the denominators are the same, do I have to consider them at all? Or can I just sort of ignore them? I can ignore them, right? Okay, so that's my philosophy on these kinds of rational equations. Let's get common denominators, and if all the denominators match, do I need to worry about them? No, I don't, because I can just look at the other structures that need to match. Okay? So if they're already matching, then I can sort of ignore that thing. Okay? There's other ways to solve these as well, but I don't think they're better. So we're going to go ahead and get common denominators, and we just did this yesterday. And the rule is factor first. So I can see that here, my x squared minus 4 is going to factor as what? X plus 2, x minus 2. So if you can factor, you want to factor that. So I did that there. And before I go any further, since I do have a rational equation right off the bat, I want to know what values of x are excluded. What values of x do not work? Positive 2 and negative 2. Very important. Okay. So right off the bat, I know x is not allowed to be 2 and negative 2, and that's always important to think about first. So from here, I'm going to go ahead and get my common denominators. I have an x plus 2. This fraction has an x plus 2. What does this fraction need? An x plus 2. So I'm going to multiply this fraction by an x plus 2. The last fraction has the x minus 2. What does this second fraction need? X minus 2, again on top and bottom. And this first fraction already has the x minus 2. So now they have common denominators. I'm just going to rewrite this so we can see clearly. 1 times the quantity x plus 2 is x plus 2 over x minus 2x plus 2. And my right-hand side has a giant common denominator. So I'm just going to write it over that common denominator. What's in my numerator? 3x minus 6, because I need to distribute my 3, minus 6x, right? Okay, so now, since my denominators match, do I need to worry about them? No. Most students like to look at a fraction is equal to a fraction, otherwise known as a proportion, and they think, how do you solve a proportion? Cross multiply, right? Do you want to cross multiply all that?
No.
I sure don't. Is it an option? Yeah.
I'm down to do this.
It's not a fantastic option though, because then you're going to have a cubic to solve. Instead, we can ignore that denominator and just focus on what isn't structurally equivalent to one another. So we're left with x plus 2 is equal to 3x minus 6x is negative 3x minus 6. The other thing, if we were to cross multiply, if I were to take this denominator and multiply it over here, wouldn't it just cancel out? Oh, so that's really what's happening here. All right. All right, so I'm going to go ahead and I guess I'm going to add 3x and add 3x. So I get 4x's plus 2 is equal to negative 6. And then what? Subtract 2. Do you have to show these intermediary steps? No, God, no. Why do I do it? Because I'm a teacher. It's what I do. All right. So I got x equals 2. Yay! Not yay. Why not yay? It can't be negative 2. We established that on step 1. Ladies and gentlemen, this is a false solution. And it's a false solution, like a false positive. So in this case, there is no real solution. What are you thinking? So just like up here, if they match, yeah, there's a lanyard right next to the flower pin. Over to the right on the wooden desk. Yeah. So if the denominators match, they're already equivalent. Does that make sense to you? Yes. Yeah. So since yeah. So mathematically, if I wanted to get rid of the denominator, I could multiply both sides by the denominator. But if I did that, then it'd be x plus 2 minus 2 on top, and x plus 2 minus 2 on bottom. It should cancel out anyway. Okay. All right. All right, ladies and gentlemen. So be careful. Make sure, especially on a rational equation, that you pay attention to the exclusions of x. All right. Yay! Quadratics.
Yes.
Alright. Here we go. Use the quadratic formula to solve. Yeah, so we're doing a lot, and tomorrow is even better because we do completing the square. And completing the square is really important. So I'm going to spend time on that tomorrow. So use the quadratic formula to solve. Ladies and gentlemen, how do you know that you have an equation that is quadratic?
That's equal to 0, right?
Oh, I know what you're saying. Hold that thought. It has a power of 2. The highest power is 2. Okay, the degree is 2. Okay. And so the quadratic formula we're allowed to use when we have a quadratic equation, equal sign, in standard form. And standard form is ax squared plus bx plus c is, Nick? What did you say? Nick,
0.
Equal to 0. That's what you were talking about. Good, good, good. So our quadratic x squared equation has to be set equal to 0. And then if it is set equal to 0, ladies and gentlemen, what is the quadratic formula? X equals the opposite of b plus or minus the square of b squared minus 4ac all over 2a. Okay. All right. I don't know if you picked up on my tune just then, but it is Paco's Weasel. And if you sing it to Paco's Weasel, you'll always get it right. So I'm just going to sing it one more time. You're going to listen really carefully. And then all day today, you're going to sing it in your head. All right. Are you ready? Here it goes. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Ah. Okay. Okay. All right. So please, you have to know the quadratic formula. If you do not have this formula memorized, you will not pass this class. I'm starting with the quadratic formula today just because it works all the time. It's kind of interesting. When I taught at the U of A, I have a lot of non-Western students. European students specifically do not learn how to factor. They only are taught the quadratic formula. And they have a hard time. It's annoying. But this does work all the time. So I'm going to go ahead and start by moving this 8x, negative 8x squared over, which is going to turn it into positive 8x squared minus 24x plus 18 is equal to 0. What do you notice about all these numbers? They're big and they're divisible by 2. So am I allowed to divide? Okay. It is an equation, and so I am allowed to divide everything, both sides, by 2, and then that's kind of nice. So we're going to get what? Okay, so you did the GCF. And can you then go and divide off that 2? Yes. So because it's an equation set equal to 0, super easy to get rid of those greatest common factors, if you will. Go ahead and get rid of it and reduce those down. Smaller numbers is always going to work out better. All right, so we have our A and our B and our C value. And so I encourage all of my students to do a lot of this work in your head. It avoids a lot of mistakes. So first we have the opposite of B. Our B value is negative 12. What's the opposite of B? Positive 12. The opposite of B plus or minus the square root of. This is supposed to be B squared. I don't want you to write it down. I want you to do it in your head. What is B being squared? It's not negative 144, you'll notice. Positive 144. Okay, and that therein lies the largest mistake in the quadratic formula. A lot of students will write down negative 12 squared, and you plug that into your calculator, and what does your calculator spit out? Negative 144. Versus the actual way you're supposed to implement that into your calculator, which would be the quantity of negative 12 being squared. And what is that? Positive 144. Negative 12 times negative 12. Okay? So it's absolutely important that you get that correct. And I just encourage you, this should always be positive. Just do it in your head. Okay? Then we have minus 4 times A times C. I encourage you to do A times C in your head. A times C is 36. Do that work in your head instead of just plugging in values. And then over 2 times 4. So we have 12 plus or minus the square root of 144 minus, which is 0. Oh, crazy. All right. So what's the square root of 0? 0. So I don't have to worry about the whole plus or minus portion. It's just 12 over 8, which reduces to 3 over 2. What does that look like graphically when our quadratic equation only has one solution for x? The parabola touches the x-axis between 1 and 2. At 1.5, it has one x-intercept, which means it must be sitting on that axis. Versus if it had 2 solutions for x, we would have 2 values for x, and it would cross the x-axis. What does it look like if it has 0 solutions for x? It's floating above or floating below, right? Okay. Very good, ladies and gentlemen. You guys may get started on class practice 11. And please remember to put your seat number on your paper.